In this video presentation, we'll learn about the Reliability Asset Management Program for heavy industry to achieve high process availability and high physical production asset reliability and utilization at the lowest risk cost, increasing revenue and profits for an organization, while recognizing the value contribution of planning services within the work management element. Now, let's look at the 4 elements and 6 processes within the Reliability Asset Management Program, referred to as the RAMP model. The first element of RAMP is physical asset management, where we highlight the asset owners, known as the Asset Management Team, or AMT. The AMT are also known as the Gatekeepers, which we'll discuss in a moment. The first and most often referred to as the asset owner is operations. Operations are primarily focused on process integrity, for example, cleaning, catalyst replacement, filters, analyzers, and so on, which we refer to as requiring a shutdown. Operations provide planning with marked up PNIDs, lockout, tagout isolations, permitting, and other key data and information. Technical is another asset owner where the inspection team will focus on asset integrity, which requires a turnaround, and the reliability department will focus on mechanical integrity, primarily rotating an electrical and instrumentation scope, which often requires an asset or system outage. Technical provide planning with inspection and test plans, along with other key data and information. Lastly, we have the engineering asset owner, made up of process, chemical engineering, and mechanical engineering, assisting operations and technical with engineering support, such as engineering work requests or management of change. The second element of RAMP is asset management strategies. This is where the AMT determines various strategies necessary for optimizing asset reliability and process availability aimed at risk mitigation and business performance optimization. This is where planning services receive significant data and information required to plan effectively. It's also where planning, scheduling, and control strategies are established, in conjunction with pre-packed systems methodology, which we'll cover in subsequent course lessons. The third element of RAMP contains work management. Within work management, we have planning services for various work types, for example, routine, major, shutdown, turnaround, outage, or capital projects. When work requests are presented to the AMT gatekeepers, they must pragmatically justify the approval to spend or invest money. This is done using a formal risk-cost-benefit analysis tool and methodology. Or, in the case of a scheduled maintenance event, a risk-based scope review process might be used. Often, to justify an expense, the AMT might request a high-level estimate from central planning. If the AMT approves the expenditure with an authorization for expenditure, or AFE, planning services will assign the work request to the appropriate functional planning resource, who will then create a work order and begin the planning process for the various work types. The next process falls under resource management with procurement and contracting prior to scheduling work for execution. A key component of RAMP is the technology and digitalization of its elements and processes, known by many names, such as Computerized Maintenance Management System, CMMS, or Data Lake, Enterprise Resource Management Program, ERP, and so on. This is where data and documents are stored and historical information is available for planning. The final element of RAMP is performance management. This is where data and information are used to continually improve physical asset performance, planning accuracy, and budget versus cost. This data, known also as lessons learned, can then be used by the AMT to improve asset management strategies, shutdown, turnaround, outage predictability, and competitiveness, and by planning services to improve planning, scheduling, and controls. To summarize, the RAMP model is an important illustration of how various stakeholders and functional teams work together for a common vision, each with their own mission. The services provided by planning, scheduling, and controls are based on a measurable mission, which we'll discuss in more detail in future lessons.